Okay, this is a video on the QCAA Mathematical Methods external exam from 2022, and this is paper 2, Technology Active. Question 1. The position of in centimeters of the particle is given by x cos 4t, where t is time in seconds. The velocity of the particle when t is 5 is, and then they give you a whole lot of options. So my approach to this one is to sketch the function first of all, and then use my derivative on my TI-84, that's second calc 6, to find dy/dx. Type in 5 when x equals 5, and the answer should appear negative 3.6518, which is answer D. Question 2, identify the correct features of the function x e to the x, and there's a number of options. So first of all, here I've sketched the function, the original function, which is x e to the x, and then I've done my second calc 6 again and found dy/dx, and that's given me a value that is equal to, well, it's it's 1.2 times 10 to the negative 7, which is pretty much 0, so we could safely say that's 0 there. I think this is the limitations of the calculator. I'm not sure, 100% sure why that isn't saying it's 0. Should be 0. Then if I sketch the derivative functions here, so you can see my y equals, there's my original function, and then I've just set the calculator to automatically sketch the derivative. When I graph that and I do second calc derivative of the derivative, that's my second derivative. So my options there, I've got a value of 0.36. So if I look at the choices, the values there are f dash of x of negative 1. So the original so the first derivative at negative 1 is equal to 0 or near enough, and then the second derivative at negative 1 is greater than 0. So the answer for question 2 is B. Okay, question 3. The derivative of the function f of x is given by f dash of x equals sine x cubed for the domain negative 1.8. X is greater than negative 1.8 and less than 1.8. The number of points on the points of inflection that the graph of f of x, so the original function, has on this interval is, well, I first of all sketched it in my calculator. I've tried to redraw it here, and I need to be aware that the point of inflections are going to occur at points where the second derivative is equal to 0, and there's a change in concavity in the curve at that point. So if I think about this as being the sketch of the derivative function, the points where the second derivative is equal to 0 are going to be there. I've circled them there. There are 1, 2, 3, 4, 5 of those, and that corresponds to answer D for question 3. Question 4, the distribution for a sample proportion p hat has a mean of 0.15 and a standard deviation of 0.0345. The sample size is, so for this particular question here, I'm just using my solver function to set up an equation equal to 0.0345, which is given, and then I've got my little formula there to calculate my sample proportion. I want to find what n is, so this is the square root of p outside of 1 minus p close bracket, so that's the mean there. Standard deviation formula is what I'm using. I press solve and I got a value of 107.12, which is closest to C, 107. Okay, question number 5. We've got the continuous random variable x has a probability density function given there. So I'm going to use this formula here, var x equals EX squared minus EX all squared. Should be bracket around that one there. This is the formula I'm going to use to help me with this. This is a continuous random variable, so our formula for the mean of a continuous random variable should be on your formula sheet, which you can use to calculate using your calculator your mean, which is which what we would have done previously to this step here. My mean of my continuous random variable would have been, I would have used my calculator to do this, negative pi onto lower bound, pi onto my upper bound, and it would have been x multiplied by the function, which was cos x over 2. Turns out that that is equal to 0. So when I use my calculator to work out that same calculation, but with the x squared part, that's what I've got on the screen there, I get a value of 0.4674. So my standard deviation is going to be the square root of my var x, so that's going to be the square root of that number there, which in this case is 0.68366. Okay, so question 5, the answer was B. Moving on to question 6. A stall at the school fete sells cups of lemonade, assuming the amount of lemonade in a cup is normally distributed, with a mean of 60 mils and a standard deviation of 3 mils. 80% of cups contain more than... So I've drawn up here, we've got what that looks like, the normal distribution here. 80% of the 80% of the cups contain more than a particular amount. I've just called it M, I don't know what that is. I'm going to use my inverse norm function of my calculator to help me solve that one, to get a value of inverse norm. 0.8 is my area there, 0.8, and 60 my mean, 3 being my standard deviation, and I'm looking at the area to the right of the value I want. In this case here, turns out to be 57.5. So the answer for question 6 is B. Okay, question 7. A marble moves in one direction in a straight line with the velocity v equals 2 ln t plus 1 meters per second, where the t is the time in seconds since the marble passed through the origin. Determine the distance from the origin. The marble has rolled after 4 seconds. So we can simply take the integral to determine that distance, and this is what it's going to look like. The integral between 0 and 4 of 2 ln x plus 1 dx. My calculator does all the work here, and we get 8.09, which is answer D for question 7. Question 8. Determine the equation of the asymptote of the function f of x log base 9 of x minus 3 minus 4. Now, essentially with this question, your understanding of that, what y equals log of x needs to, you need to have that basic understanding, knowing that that function will have an asymptote at y equals 0. This one here, because it's y equals log base 9 of x minus 3, that's as a shift to the right of 3 units. So instead of the asymptote being at 0, it's just going to shift over to the right for this one. So your answer for this question is simply C. So this question here, if you know your stuff, this should take less than about 10 seconds to answer that question here. Alright. We're up to question 9. Question 9, determine the length of the side AB in the triangle ABC. So again, this one here, we're going to use our knowledge of the sine. And if we set up our equation like this, we've got 12 over sine 30 equals AB over sine 37. Now 12 over sine 30, now I could just use my calculator to work this out, work out what AB is, but I just happen to know sine of 30 is a half, 12 divided by half is the same as multiplying by 2, so this is 24 sine 37. That is what AB is going to be. So if we put that into our calculator, I got an answer of 14.444, which is answer B for question 9. On to question 10 now. The solution of e to the power of 2x minus 3 equals 42. For this one, I simply put that into my solver on the calculator, set up an equation, e to the power of 2x minus 3 on one side, 42 on the other, and I've got an answer of x equals 3.36, 3.37 rather, which is answer C. So that is paper 2 of the QCAA 2022 Technology Active multiple choice questions.